Here I've drawn a straight line in purple pen, and I want to find the equation of this straight line. It's drawn on a set of axes where x is across and y is up. Over here we have the general form of an equation of a straight line, where m represents the gradient of that line and c represents the y-intercept. Well, the value of c is quite easy to spot when the graph's drawn like this. It's where the line intersects, that is, crosses the y-axis. So our value of c for this purple line is going to be plus 1 because it intersects here at 1. Let's start writing this down in purple. So I've got y equals, I don't know what the gradient is yet, that's going to go before the x, but our value of c is 1, so I'll write plus 1. Now to calculate the gradient, I'll choose a point on the line. This one's quite convenient actually, I'll use that one. For every 1 that I go across, how many do I go up to get to back on the line again? So our change in y here is 2, and our change in x here is 1. It's 1 across and 2 up. The gradient of this line is the change in height divided by the change in the horizontal distance. So here I've got 2 divided by 1, which is 2. For every 1 I go across, I go 2 up. So our value of the gradient here is 2. The equation of this straight line is y equals 2x plus 1. Here I've drawn another straight line, this time in pink, and I want to find the equation of this line. It's much shallower than this one, as in it's less steep, so I'm expecting the gradient to be less than 2. Let's find out. Well, I'll use the pink pen to write it out. So y equals, not sure what the gradient is yet, so I'll leave that blank, but I can identify the y-intercept by looking at this graph, and it's crossing the y-axis here at -2. So I will put -2 here for our value of c. Plus -2 has the same effect as taking away 2. Now what's the gradient? Well, I'll choose a point on the line. This one's quite convenient, I'll use that. So for every 1 that I go across, how much do I go up? Well, it's not very clear here, so what I'll do is I'll keep going to this point so that when I go up, it's touching in like a really nice point. I can see that that bit there is on -1. It's really clear to me. So the change in y here is 1, and it's gone across 3. So the gradient of this is the change in height, which is 1, divided by the change in the horizontal distance, which in this case is 3. 1 divided by 3, well, I'm going to leave that as a fraction rather than a decimal, because it's much nicer to work with. So the gradient of this line is 1/3. So I will write 1/3 here before the x, because that's the gradient of the line. So the equation of this pink line is y equals 1/3 x minus 2. Now I've got this blue line. I want to find the equation of this line. Again, the intercept is easy to spot. There it is, it's at 5. So I'll write it in blue. Y equals, I'm not sure what the gradient is yet, so I'll leave a space there. But I know it's going to be plus 5 at the end because the y-intercept is at 5. Now what's the gradient? This time it's going down instead of up like the other two. So this line here, the blue one, has a negative gradient. So let's see what happens. Let's choose this point again. So I'm going to go down 1 this time. So I'm going to put a -1 there, and I'm going across 2. And remember, the gradient is the change in height divided by the change in the horizontal distance. Our change in height this time is -1 because it's gone down. So I'm going to do -1 divided by our change in the horizontal distance, which is +2. So -1 divided by 2 is -0.5, but I'm going to leave it as a fraction So I'm going to write minus a half, which I think is much neater when we write out equations. So here I will write minus a half as the gradient. So the equation of this line here, the blue one, is y equals minus a half x plus 5.